Welcome to Module 6.1. In this module, we'll be exploring the basics of linear perspective. Perspective is important because it gives the artist the ability to draw an object so it appears in 3 dimensions on a 2-dimensional surface. Perspective is not only used to make objects appear to have dimensions, but it can give the illusion of space to your objects. Take this image of a railroad track in a field. The land is even in all directions as far as we can see. At the point where we see the sky meeting the distant plane in a long even line is called the horizon. We could consider the horizon to be a continuous line, and it is true even if the horizon is obstructed by an object such as a building or a mountain. The horizon still exists even if we can't directly see it. If objects were transparent, the horizon would be seen. Observing the rails of the track and the power lines, we see them recede on the plane. They diminish in size until they reach the horizon. Since the lines are practically parallel, they converge and are lost from sight in the distance. The place they converge and disappear is called the vanishing point. To understand how perspective works, let's begin by talking about the picture plane versus the ground plane. The picture plane is a flat 2-dimensional surface on which we draw or project an image in perspective. In this illustration, it's a simple task to draw 2 rectangles as if they are parallel to their picture plane. The ground plane is at 90 degrees to the picture plane and is what causes pictorial illusions of perspective. In our illustration, the ground plane is the gray surface in which the shapes appear to be standing. It's emphasized by the shadows which are cast upon it. It starts at the bottom of the picture plane and stretches back to the horizon. The difficulty in drawing our 2 rectangles arises when you need to illustrate them at an angle to the picture plane. This is where the rules of perspective drawing come into play. See how the perspective of the illustration changes when we switch focus from the picture plane to the ground plane. The rectangles are now seen at an angle of 90 degrees to the picture plane as they recede along the ground plane. This creates an illusion of depth. Their shapes are no longer identical, and they have changed according to their rules of perspective. Since the forms are parallel to the ground plane, we can predict how they will recede. To see how these rectangles will behave in perspective, we can trace their orthogonal lines. Orthogonal lines are parallel to the ground plane and move back from the picture plane. These lines set the varying heights and widths of rectangular planes as they recede from view. Orthogonal lines always appear to meet at a vanishing point on the eye level. On the other hand, there are transversal lines. These lines are always at right angles to the orthogonal lines. Traversal lines are parallel to the picture plane and to one another. These lines establish a fixed height or width between 2 orthogonal lines. Transversal lines form the nearest and furthest edges of a rectangle as it recedes from view. The term horizon line and eye level are often used synonymously. However, eye level is the height of the viewer's eyes when looking at an object, whether it's interior or exterior. The horizon, or eye level, is the axis around which perspective drawings are constructed. When drawing perspective, the horizon also happens to be your eye level. In art, we tend to use the term eye level rather than horizon, as in many pictures, the horizon is hidden by walls, buildings, trees, hills, etc. One-point perspective is so named because it uses a single vanishing point to draw an object. It's the simplest form of perspective drawing and is used here to draw a box. In one-point perspective, the front and back traversal planes of the box always remain parallel to the picture plane. Only their scale changes as they recede into the distance. In this demonstration, you can see how the rows of cubes behave in one-point perspective. As I change the viewpoint, the orthogonal lines move, but the vanishing point is always connected to the horizon or eye level. Here I'll move the eye level to a bird's eye view. While still staying in one-point perspective, we can see the orthogonal lines still recede to the horizon. Here I'll move the eye level to below the cubes. While still staying in one-point perspective, we can see the orthogonal lines still recede and converge on the horizon. The transversal lines remain parallel to the picture plane. Now let's use our knowledge to study one-point perspective in the real world. This street scene is taken at one-point perspective. We can see where the horizon line is based on how the orthogonal lines behave. As orthogonal lines approach the horizon, their angle becomes more acute. Here I've color-coded the buildings based on the planes they're on. The ones in purple are along the orthogonal axis, while the blue ones facing us are along the transversal lines. Two-point perspective uses 2 sets of orthogonal lines and 2 vanishing points to draw each object. To demonstrate this, let's look at this brick. Here we have a brick flat on a surface, so 3 of its sides can be seen. Now we'll extend the orthogonal lines and locate the vanishing point and the eye level. After locating the point and line, turn the brick a little more. This changes the vanishing point, but the eye level is still the same. The more we turn the brick, the more the vanishing point changes, but it's always along the same eye level. You'll notice at this point that we have no more transversal lines. Now it's all orthogonal lines. Here we find another set of parallel lines representing the width of the brick. Here we have the brick just as before, but with its length lines extended to a vanishing point and the eye level line passing horizontally through this point. The width lines, in blue, also meet at a point which lies on the very same eye level line as the point reached by the length lines, in red. This is because when we look at 3 sides of a brick as it lies here on a level surface, our eye level remains unchanged whether our attention is fixed on one group of parallels or the other. We can see this in action in this series of cubes. As we rotate our viewpoint, the orthogonal lines shift until suddenly we see one point in perspective because only 2 sides of the cubes are present. As we turn the cubes some more, we find that our first vanishing point moves away from the cubes along the eye level, while a new point moves towards the cubes. As we turn it even more, we can stop at this point and see the vanishing point is off the screen here, while another vanishing point is off the screen here. Perspective drawing with 2 vanishing points can sometimes become awkward because second vanishing points are often situated well outside the frame of the picture. If both vanishing points were situated within a picture frame, the angles of the objects would appear to be extremely foreshortened. Here, like the earlier example, we'll apply our knowledge of 2-point perspective to a real-world example. In this city scene, we're looking at a group of buildings in 2-point perspective. You can tell it's 2-point perspective because there's no transversal planes. First, we'll establish the eye line. Here you can tell it's fairly low because all the orthogonal lines on both sides lean towards a low point of view. We'll then start to mark out our parallels within windows and building tops. You should notice that the line will converge at their respective vanishing points. Both vanishing points here are off the page, but we can tell where they are based on how their lines converge. Lines closer to the horizon will be sharper angles than lines further away from the horizon line. You can then trace them back to their vanishing points by extending the lines and seeing where they converge. Again, I've marked the buildings based on their respective planes. Since they're both on orthogonal planes, I've colored them based on which plane they're on. The blue faces of the building follow one set of orthogonal lines and the purple follow another set. On occasion, you may find yourself with objects that don't necessarily match your understanding of perspective. In this still life with 2 vanishing points, the orthogonal lines of the pedestals show that they're all parallel with each other. This is fairly easy to construct in 2-point perspective. However, if you notice the cups in the foreground, they're at an angle to the pedestals. The vanishing points will be different too, but they'll always converge in the same horizon line or eye line. This is still 2-point perspective, it's just a matter of applying another set of points to objects that do not necessarily conform with the original angles. Cylinders in perspective. Cylinders are made up of a series of circles. Circles in perspectives are called ellipses. These ellipses are parallel to the ground plane. Here in the cylinder, you can see it's formed by circles being projected vertically from the ground planes. The ellipses that outline the cylinder are all the same width. However, the roundness of their curves gradually increases as they rise above or drop below eye level. Note how the ellipse at eye level is seen as a straight line. Because an ellipse is a distorted circle, it will never have flat edges. This is a common mistake many beginners have when rendering cylinders in perspective. Even if portraying the top of a cylinder that is at eye level, the sides will never be squared off. They will have a slight curvature to them. When drawing cylinders, it's often best to start with top and bottom ellipses, and then try to figure out their place in perspective relative to each other. Once you have the ellipses perspective figured out, extend lines from the bottom to the top. This will give you a cylinder in perspective. Oftentimes, when drawing cylinders, it's good to have kind of a loose hand. I establish my eye line, and then draw ellipses based on that eye line. As you finish, be sure to round out the top and bottom to avoid pinching the sides of the cylinder. This concludes Module 6.1, Basic Perspective. Please proceed to Module 6.2 for demonstrations on how to paint glass and glass bottles.